Hello, everybody. Here we are at our, somehow I can't believe we've got here, our challenge finale event this evening. So it's really lovely to see everybody here. We are delighted to have you joining us. So this is the final of 6 sessions. So we had the solving problems with Python MOOC, followed by a challenge. And I've got some audio problems here. There we go. Hopefully that has fixed those audio problems. Sorry about that. So completely lost my stream of where I was. Bear with me. Let's have a look. There we go. Sorry. The magic of technology is that technology can betray you at any time. So that's just something to keep in mind. So anyway, backstage, you've got me, Jodie. So I'm from Code First Girls, as you're probably very aware by now. So I am the CFG MOOC host. So if you've got any questions about CFG or other upcoming classes and events, please do put them in the YouTube chat and I will try my best to reply during the session. A little bit of background on me. I started coding about 2 years ago. I took some MOOCs and some Kickstarter courses via CFG, plus a few others elsewhere. And then I got onto the CFG degree in the spring cohort of this year. So I did the software stream and then went on and did the DevOps Masters. And then I started the job that I got via CFG as an associate developer at the Houses of Parliament almost 3 months ago now. So that's been a really exciting and wild ride so far. So that's been cool. If anybody does have any questions about the CFG degree, I'm very happy to answer those in Slack or in the YouTube chat as normal. So the Solving Problems with Python MOOC and Challenge is sponsored by GCHQ. So GCHQ are the government communications headquarters, and they are tasked by the UK government. They are a world-leading intelligence, cyber and security agency. They unlock the complex world of data and communications to keep the UK and its citizens safe, both in the real world and online. They work closely with government partners to protect the UK from threats, including serious organised crime, terrorism and cyber attacks. GCHQ are extremely proud of their purpose and their people. So to find out more about GCHQ, please visit their website, which I will pop into the chat shortly for you to have a look at. I will also post some links for some other MOOCs that CFG are running, just in case those are of interest to you. Anyway, so what are we doing this evening? We've had some really great submissions. It was really difficult to pick our 3 finalists. So a big well done to everybody that's got involved with the challenge, everybody that got involved with the MOOC. It's been really impressive to see all the work that you've come up with. So just to give you a quick overview of the structure of this final session, basically I'm going to hand over to, I think we've got Raz from GCHQ. They're going to do a little bit of an intro. They won't have their camera on for security reasons, which are probably fairly obvious to everybody. And then after we've heard from Raz, the lovely Sam is going to take you through some very brief slides, just outlining the challenge that you were given. And then we will have the presentations from the finalists. There's then going to be a brief pause of about 5 minutes where GCHQ will decide who has won. And once the live judging is complete, we will then announce the winner. So as before, if you've got any questions throughout the session tonight, do put them in the chat and I will try my best to answer them during the session. Or you can also use the Slack and tag either me or Sam, our instructor, or the CFG programs teams for any kind of specific questions. So I'm now really happy to welcome Raz from GCHQ to the stream to say a few words, and I hope you enjoy the session. Let me just add them in now. And hopefully... There we go.
Can you hear me?
Hello.
Hi. Thank you everyone for taking part in this. It was quite exciting to see how far, just how impressive some of the submissions have been. You guys have done quite a bit more than we were expecting the majority to get through, so very well done. Probably a bit of an intro to where the idea for this competition came from. As part of one of our missions is cybersecurity. And one of the big things is malware that we discovered in the UK. And this kind of gave an introduction to both using your Python skills you guys have been using, but really thinking beyond just some of the basics that you learned during a course, like how things can be twisted sometimes to make things a bit devilish, and hopefully made it a bit more interesting than just being given a few Python projects.
Awesome, thank you. That was really cool. So I am now going to hand over to Sam, who's got a few slides to take us through. So let me just get Sam on screen. Where have we gone? We've got quite a lot of people backstage tonight, so it's a bit more hectic than usual. So let me get Sam added. There we go, and we'll add Sam's slides. And I'll let you take it away, Sam.
Thank you very much, Jody. Hello, everyone, and welcome to today. I mean, long anticipated, and I'm really super excited to run today's session. It's somewhat different from what we expect. We're not writing any code. Rather, today is the day we reveal the top 3 finalists, and we'll have a winner and 3 other super cool teams, because I don't believe like you've got winners and losers. Nope, we've got winners and we've got other teams that are also super cool. So yeah, I will now proceed to the slides, so please bear with me. It's going to be super short, and thereafter we will proceed with the teams that are going to present today. So yeah, welcome again to today's session. I already said all of that. My name is Sam, and it's been an honor and a privilege to be your instructor throughout this MOOC. I hope to see you in future MOOCs. So yeah, stay tuned, and let's see how that goes. The challenge. I have a drum roll prepared, and I hope you can hear it. So I'm just going to play that. Okay, so hopefully you heard that okay. That was just some drum roll here. Okay, good. So we are here for something very important, and that is the challenge. The theme had been Python reverse engineering, and as the delegate from GCHQ had said, it's actually it's one very cool task, and also very unconventional. It's not some sort of task you see every day. So I mean, looking at it from an instructor perspective, I was like, wow, this is super cool, and something that should challenge the students. So I'm really happy that you had to do this, and you had to challenge yourself throughout this. So I'm just going to give you a quick recap of the whole Python challenge for individuals that probably didn't follow through, and for our guests. This is gonna introduce you to the whole scope of the challenge, and then when we have the teams talking about this and talking about their task, we are on the same page and we understand everything they've got to do. Yeah, so the task had been Python reverse engineering, and this again is in collaboration with GCHQ. Super thankful for the opportunity. It's been 4 weeks. It's been 4 weeks of learning, and it's also been also additional weeks of the challenge, all to deepen your understanding of Python and to gain practical hands-on experience in reverse engineering. Reverse engineering is some concept, I would say probably a heuristic, that is about helps you be meticulous, trains you to be more meticulous, to look into detail and to try to like fish out certain things going on, and things that work, things that do not work, and why they do not work. So it's very synonymous to kind of like an analogy of looking into like malware, trying to like debug and understand why certain aspects of your code work. Now let's get into the challenge. All right, this challenge had been in multi stages of Python debugging, and I'm sure refactoring and inspecting of codes. It's been really cool, and I mean throughout this challenge, I'm sure our students have been able to explore certain intricacies in Python, and also learned about the ordeals in runtime, and also to just have some really cool hands-on experience. This challenge is encapsulated around 5 certain degrees of concepts and tasks that you have to have arrived at. So throughout this challenge, you've been tasked to look into the actual Python program and what it's designed to do. You've also been tasked to look into the processes and the methods that were employed intentionally to, make things a little bit obscured, so the tricky aspects of things. It had been the responsibility of the students to try to like investigate and fish out the things that were put in intentionally to, make it look a bit obfuscated. Yeah, so today we are going to have 3 finalists, 3 teams that will present their challenge. These 3 teams, we're going to have 2 members of these teams back on stage with us, and they will in turn, talk about their challenge and how they went about it. They will also have a presentation, to show us, and we will be the audience cheering, all of them, and rooting for the best team. Good. Now, thereafter we're gonna have a very short break, and the GCHQ team are gonna, deliberate on who will be announced as the winning team for today. And like I said, we've got winning teams and we've got cool teams that actually everyone, I'm sure, puts in ample time and resources into getting to this stage and also participating. That's the biggest flex. So thank you all for indulging. Good. So now I'm going to talk about the judging criteria, which is very important especially for the teams that are going to be presenting today. We have a variety of rubrics based on innovation, collaboration, presentation, and adherence to challenge theme. So in the case where we have like a team that is made up of like an individual, which is also allowed, in that case, the collaboration criteria is going to be like taken out, and the rest of the criteria are going to be weighed evenly. Okay, so this makes it very transparent and very fair, okay, to all of the team, regardless of okay, I worked as a team or I didn't work as a team. So at this point, I am super happy to have Judy come back on stage and introduce the team, and let us have this started. Thank you very much.
Hello, so I am just going to remove Sam's slides and then swap Sam's slides for my slides. We've got a lot of different slides this evening, so I do apologise in advance for all of the slide swapping that we will be doing. So so we're now going to crack on with the presentations from the 3 finalist teams. So our first team to present this evening is Team Green. So that team was comprised of Kath, Beth, Kirsty, Nada and Manda. And this evening presenting, we have got Nada and Kath. So I'm now going to add Nada and Kath to the stream. So I hope you're ready, ladies. So let me add you in here. So now hopefully you can see yourselves. So there we go. So say hello to everybody. I'm going to take my slides off and I am going to add your slides there, Nada. So you will now have control of those slides, and I will leave you to it and let you do your presentation.
Awesome. Thank you, Jolly.
Thanks, everybody. So we're going to whiz through a little bit because it's quite tight for time. So thanks very much. Welcome to Team Green's Python challenge presentation. I think the first step is to introduce the team. So as we've mentioned, we have Nada, Manda, Kirsty, Beth, and myself, who've been really great to work with. So thank you, ladies. And the structure of our presentation is going to be that we start off by addressing the 3 challenge questions. Then we're going to reflect on the judging criteria and hopefully have time for a couple of questions at the end. So the first question was, what are the Python programs designed to do? So we're going to look at each of the programs in turn. So the first Python file, hidden1, that takes 2 numbers as input. It finds their absolute values, sums them and prints the result. So on the previous slide, we did have an image of the reverse engineered code that was produced by Team Green. And then just to confirm, we're going to input 2 numbers. The example here is 2 and -3. Hidden1 is going to sum them and print the answer, which is 5, obviously, in the terminal window. The second file, hidden2, takes a single integer as input. If 0 is input, it prints the word 0. If an odd number is input, it subtracts 1 and prints the result. And if an even number is input, it adds 2 and prints the result. So here we have the example of inputting -4. And in that case, obviously, it's an even number. So the program is going to add 2 to that to give the result -2 and print that in the terminal window. The third Python file, here's an example of our reverse engineered code. It takes a single integer as input. If 0 is input, it prints the word 0. If a positive integer is input, it calculates and prints the square of that integer. And if a negative integer is input, it calculates the -n+2 term of the Fibonacci sequence. So in the case where we were to input as an example -8, that's obviously a negative number. So the program's going to calculate the -n+2, which in this case is the 10th term of the Fibonacci sequence, and print the result, which is 34 in the terminal window. The fourth challenge file was slightly different in that it requires a string as input. So it's going to split the string using any white space as a breakpoint. 0 length substrings are ignored, and substrings of length 1 are set to lowercase. Any substrings with length greater than 1 have their first letters capitalized, and the string is then rejoined with white spaces and printed. So in this example, we've got the lowercase string in the top green box there. Each of those words are separated by white space, which become the breakpoints, and each word is going to be capitalized because they're all of length greater than 1 character. And the final result is the bottom box there. The fifth file, again, takes a string as input. That string is again split using white space as a breakpoint, and 0 length substrings are ignored. All the other substrings are reversed using the slice method, and each substring is then inspected in a nested for loop, and any non-alphanumeric characters are replaced with a single hyphen. The substrings are then joined back together, separated by white spaces. So if we take the example of hello, exclamation, code purse girls, each of those words is split at the white space, and the characters within each word are reversed, and the exclamation mark and the full stop are replaced by hyphens to produce that difficult to read output in the bottom blue box there. We then moved on to have a look at the bonus challenge, which I think it's fair to say was a bit of a step up in terms of complexity, but really good fun to work on. And obviously in terms of, it was quite difficult and complex to begin with, but we managed to simplify it to that quite straightforward script file that you saw on the screen just there, which produces, I think, the same output as the original obfuscated code. So the bonus file takes a triple quoted string, it reverses it and writes it to a new file called request.py, and that new file is then called and executed by the original bonus file. A list of what appear to be IP addresses in request.py is processed by user-defined functions to provide a string that consists of valid Python code, and that string is then executed using the built-in exec function, producing a file called secret, which contains the message, well done, you've found the secret message. And then confusingly, an error message is printed in the console window, which suggests that the program hasn't run successfully. In terms of the reverse engineering process and methods that we used, we started off by running the code, inspecting the output and rerunning it with different types of input. We reformatted the code, removing semicolons and separating operations into different lines to enhance readability. We identified variables and renamed them with descriptive names, identified imported modules and ensured that they were descriptively named as well, and removed any naming conflicts. We made use of snake case naming convention to enhance readability, and placed print statements at strategic points within the code, or ran sections of the code in the console to better understand its behaviour. We continually tested our reverse engineered code throughout the refactoring and reformatting process to ensure that the changes made didn't affect the functionality of the code. Techniques we used to make the program used to make reverse engineering more difficult. There were no header comments or descriptive comments within the script to explain its functionality. It wasn't immediately obvious what input was required, and it wasn't immediately obvious how to run the code either. There was cryptic renaming of common inbuilt functions, cryptic and non-descriptive variable names and naming conflicts were used, and operations were often combined into a single line using unconventional layout. There was unnecessary complexity and redundant code, and in the case of the bonus file, sort of confusing use of errors. In terms of the judging criteria, we tried to take a unique approach to the challenge. We worked independently on the codes and posted our answers for feedback and improvement, which improved our code quality and improved our understanding. And we used Notion to develop interactive reports containing embedded code that demonstrated our solution at the click of a button. We collaborated by initiating our team with a meet and greet to introduce ourselves and brainstorm our approach, and we made good use of Slack, Notion and Google Workspace to post and discuss our solutions. In terms of our presentation, we've tried to make sure it's visually appealing and developed our interactive reports to demonstrate our results. And in terms of adhering to the challenge theme, we've addressed each of the challenge questions, provide detailed written reports, and presented our work as required by the timeline. So I think all that's left is to say thank you very much to everybody involved in developing the challenge. And thank you very much to all my colleagues in Team Green, because you were all great to work with. And if anybody has any questions, feel free. Thank you.
Thanks, guys. That was a really great presentation. That was really comprehensive and really clear. I really like your visuals. I thought that was really great. I'm just going to give GCHQ an opportunity if they want to ask any questions now. I've just added you back to the stream, Raz. So if you've got any questions you'd like to ask.
That was really impressive. Well done with getting through all the steps. That was quite nicely explained with all the steps. Yeah, it was really impressive. Probably one question is, what did you find hardest about trying to collaborate on these sort of challenges? I presume you were all remote from each other?
Yeah, we're all remote. And I think the hardest part is actually trying to find time in everybody's diaries, because everybody's busy, aren't they, these days? So we did have, it wasn't the case that we could all get together at the same time, all the time. So we did have to break it down a little bit, but that was fine because we were able to update each other as well on what had gone on in each little meeting and stuff. So it worked well.
Nice. And with the bonus challenge that we threw in about halfway through, how did you first start approaching that? Because you mentioned it is quite a step up from the first ones we gave you.
Yeah, so I think the first job, I kind of I took an intermediate step on it. So speaking about my own experience with it, I kind of took an intermediate step. So I realized that it was writing the second file. So my first job was basically just to combine that into a single file. And then once I'd got the request.py file, just to work on that one separately and to understand that. And then once I understood that one, to take it back to see what was going on in the original bonus file and how it was being called and executed.
Nice, yeah. That's sorry, did I step on someone there? Oh, cool. Yeah, that sort of breaking down the problem is exactly what we have to do during reverse engineering, because you have to start from somewhere and figure out what you do know and break it forward from that point. So very well done. Thank you.
Thank you.
Awesome. That's great work, guys. We don't have any questions in the chat or anything, so I think I will pronounce you guys as completed and free to go. So let me take you off of the stream. Well done. You can relax now. Now you've gone first. You've done the hard bit. So let me pop everybody off. So we're just back to me. So our next presenter is going to be Janet. So Janet worked on their own. So Janet, if you've got some slides, there is a share screen button that you should be able to see. So if you can share those slides, and then we will be able to see you. Let's take my slides off. We're just having a little bit of a technical difficulty here with the slides. Bear with me one moment and we will just get those sorted for you. Janet, I'm just going to add you to the stream so that we can see and hear you. Hi, Janet. How are you doing?
Hi there. Yes. Yeah, good. Thank you.
So you should have a share screen option sort of bottom middle somewhere.
Yes. Let me just see if this is coming up.
Ah, there we go. I will share those.
Thank you.
There we go. Okay. So you have control. I will let you crack on. Good luck.
Thank you so much. So I'm Janet. I currently work in HR. I did do a degree in physics a very long time ago, but I've been learning to code in Python for a little while in my spare time, and I'm in the process of career switching to tech. So if I can just, excuse me, just need to move to the next slide. I'll just do it on that screen. I apologize. It's got the other notes, but it's a little bit easier the way I've set this up, unfortunately. So, so these were the requirements, and this structure I found really helpful. So for the first 5 challenges, I started to build up the report as I went through each of the 5 scripts, which the previous team have explained in some fantastic detail. I found this really helpful. It stopped me doing just random things, made sure I had to think about what I was trying to do and to start to develop a fairly systematic approach. So just bear with me. And to help me keep track of progress, I set up a project in a GitHub repo. I also did some research into reverse engineering in Python, and these 2 articles I've highlighted, they were really helpful for me, some really clear explanations and a pretty digestible format. So this was the approach that I developed. There were 3 techniques that were really helpful for me. Basically going through the code line by line commenting. I found with my IDE, which was PyCharm, I was able to use the warnings and the debugger to step through code where I needed to. And if nothing else, it pointed out things like syntax errors, failures to follow whitespace conventions, unused and shadowed variables. And what I would do with each set of the first 5 scripts was to basically try and clear those warnings as an absolute minimum. And then the other technique that was super helpful for me anyway was the print function, which allowed me to print off various variables, print off some of the strings, and also to check out some of the data types as they were sort of being moved through the code. So all these approaches came together for me in the final script, which is the challenge.py. But unlike the previous scripts, I didn't really know where this one was trying to go just from looking at it. And so I had to adapt my approach in this case. And so what I did was to treat it like a jigsaw really and break it down into smaller parts. And because I didn't know with this one what solved was going to look like, I sort of just had to keep at it. And I thought I would just report on whatever wherever I got to with it. But actually, I think I sort of got most of the way through this piece anyway. So just talking about those sort of jigsaw pieces as I saw them, I think the first piece for me was the big doc string at the top of the challenge.py script. It looked like it had been reversed, and it looked like a script in itself as well. The second jigsaw piece that I started to look at was the get request at the end of the challenge script. I noticed it gave the wrong response. It gave a non-response rather than sort of the expected 200 response. And I ran that little bit of code in a separate IDE, and it did return the 200. So I knew there was something in that code that was doing something odd to the output. I then tracked back, and the third piece then for me was the fact that you have a script in challenge.py that looks like it's been written, and then it wasn't appearing in my directory. So having worked through that challenge.py bit of script, I saw that by commenting out part of the code, I could get that request.py, so this other script, to stare my directory, and then I could work through that and sort of start to understand what it was trying to do. So having retained that request.py file, I was able to apply those sort of similar reverse engineering techniques to it. And this is where the research that I'd done was helpful. And it talked in there about how string manipulations often used as a technique for obfuscating code. And so as part of the reverse engineering of the request.py script, I printed the strings in the 2 of the functions, and they showed the sort of the well done, you have found the secret message. And you could also see in those strings that they also wrote a further file, which is the secret file, through the exec function. So it was while I was researching and working through the challenge.py script that I started to get a real sense of how obfuscation could be used actually maliciously. So unlike normal comments in Python, the doc strings are accessible during runtime, which seemed like a way to potentially make real trouble for somebody. And also learning about, for example, the exec function, which dynamically executes Python programs, whether passed to it as a string or a code object. So there was a sort of an underbelly of coding that sort of, for me, that came out of this challenge that I hadn't explored before, but was fantastically useful to have had some experience of. So going forward, I identified some things that I would like to look into a little bit more, and I think these are probably just the top level of things I'd like to look into. I think I may have come away with more questions than perhaps I answered, but it was a fantastic opportunity. And I wanted to say, thank you for the opportunity to share this. Thank you for being part of this community, frankly, that's prepared to talk about obfuscation of Python at 8 o'clock on a Wednesday night. So thank you very much.
Hi, Janet. That was great. And yeah, I think you've really hit upon something that is a fundamental truth in any coding, is that you will always end up with more questions than you do answers. So yeah, that is definitely something that I've experienced as well. So I will just pop Raz back on as well in case they've got any questions. I just wondered if I could ask a question, actually, like, how did you find working on your own? Did you find it quite daunting, sort of working on your own, or were you kind of quite happy just to go at your own pace?
I've generally found working in teams to be much, much better. So much better. I'm very happy to work on my own, but I much prefer working in a team. But I'm just super busy at work at the moment. So my fear was I couldn't really commit to a team effort. So I thought, well, I'll just give it a go. And well, if I was only going to let myself down, I suppose. So it's not my preference. I am happy to work on my own. But I just think there are layers of benefit from working in teams, particularly something like this. That's why I did the GitHub repo, because I needed to keep myself on track. Yeah.
Nice. No, it looks like you did really, really well. Raz, have you got any questions?
I'd say it's really well done, and I like how you structure yourself and get yourself very organised with these sorts of projects. It is very easy to go off down some rabbit holes. Especially liked how you started talking about how we could have gone further, made this even more challenging for you guys. I was kind of curious as to how were you starting to, was that just based on some documentation you were reading, or were there resources you were pointing yourself towards when you were looking at that end?
I think there was so much of it, actually. I think at the start, when they talked about it's the amount of detail you sort of start to look into, I started to look into things like the exec function I'd never really thought about. I'd never thought of doc strings other than just a big lump of comments, and actually it having the potential to be something in a way malicious. They were just ways of thinking about the code that hadn't occurred to me before. There was, in the request.py, when it started doing the character encoding, I hadn't really got my head around some of that stuff, and bytecode I'd never heard of. It was just, it ended up being layers and layers, things that I realized, I always think Python's an interpreted language, but it must be compiled somewhere. And so actually it just made me start to think at a deeper level about the code. I'm not sure. I'd never even heard of reverse engineering actually prior to this. So yeah, it was like my blinkers were off to a whole other side of code, really. I suppose I'd approached it quite naively up to now.
Was taken directly.
Thanks. Yeah, that was that can go down massive rabbit holes, this end. Yeah, it was very well done. Like you mentioned like using the doc strings. That was one idea that one of my colleagues came up with, but we all thought, oh, that's far too evil to give you guys. So very nice thinking of that.
I think lambda functions would have been, there was one little lambda in there, but that struck when I was doing the research. The lambda functions look like you could be really mean. I think they're quite tricky too.
Yeah, this can get down to all sorts doing various stuff.
The IP was taken directly from Hive ransomware. So if you had,
sorry, I've got someone talking into my ear, so I got quite confused then. The IP addresses that were encoded at the start, and the weird encoding I was doing there was actually something we took for inspiration from a piece of malware that was found publicly.
Yes,
where
I did try and ping an IP address and was getting nothing.
Oh dear. So the idea was someone was doing that to hide, just like we had done, hide what they're actually doing. And to anyone who looks at it without really digging it apart, it looks not that weird. Although a bit odd, but not like clearly obvious that's where you're hiding your nice juicy malware. So yeah, it's really nice to see that you're thinking beyond the evil tricks we pulled and how to go further. Thank you.
I'm just trying to get more evil now. Cool.
I can always sense the notes being made to make it more and more evil as time goes on. So that's good. Excellent, Jack. That was amazing. Thank you very much. I will take you off the stream now. And then we are going to go back to my slides. So finally, our third set of finalists is Team Lime. So as a team, we had Rebecca, Eleanor, and Catherine Ann. And then presenting, I think we've got Rebecca and Eleanor. Sorry, Becky, apologies. Let me add you both to the stream. So there we've got Becky and Eleanor. So whichever one of you has got slides, if you could share them using the share screen button at the bottom, I'll put my teeth back in and then I can get those on the screen for you as well.
Do you want me to do it, Eleanor? I can try.
Yeah. There we go. I can see those. There we go. So I will take myself away and let you crack on.
Okay, I'm not actually sure how to put it into presenter, so I'll just go through them like this. So, oh, Jodie.
I was going to say, I think it's normally if you press F5, but we can see it without, if you'd prefer to have your notes or what have you, that's fine as well.
I'm pressing F5, but it doesn't work. Okay, I'll just go through it. I don't mind.
It's one of those times it doesn't. Apologies.
Right, so we're Team Lime, made up of Becky, Eleanor, and Catherine. So I'll give you an overview of our approach to the challenge and how we have reverse engineered the programs. So I think our approach was quite successful because we actually had really good communication and teamwork during the challenge. We divided the workload, so we each had the same amount to do. We had working documents for our code and shared this via Slack. So this meant that we had a record of all of our workings. We could check over each other's work and provide feedback. And then for the final submission, we had a huddle to decide what to do, and then created documents on Google Drive we could all edit together. So we noticed that there were some shared themes between the programs. This was kind of a starting point for getting, starting the challenge. So all programs use the sys module to take command line arguments and then perform calculations or manipulations with them. So as we're new to Python, I'm completely new. The MOOC was the first exposure I've ever had to Python. One of the first steps was actually to read about the sys module and understand what sys.argv actually is and does. We also noticed that the programs were using similar tricks to make the reverse engineering more difficult. So unnecessarily renaming Python functions and modules, having illogical and unhelpful variable names and error messages, writing single line code where it could be split across multiple lines and be more easy to read, and also not including any comments to help the user. So in order to reverse engineer the code, we had to first understand what the programs were actually doing. So we ran the programs with a range of different arguments to see what would happen, then rewrote the code to address the issues that I just mentioned, and then ran them again to check that we actually got the same answer. Right, so we're now going to go over our, each program briefly. So hidden one takes two integer or float arguments as inputs and then returns the sum of the absolute values. So on this slide, we've got a couple of code snippets to demonstrate our reverse engineering. So firstly, not renaming the float function, print function, or sys module, so it makes it a lot clearer as you go through the code. Using something more logical than just the letter C to store the arguments list, and then expanding out single lines of code and adding more descriptive error messages to help the user. For hidden 2, takes one integer's input. If it is 0, it will print 0. If it's odd, then it will print the previous even number. And if it's even, it will print the next even number. So there's an example of our code here, but as the reverse engineering techniques used were pretty much the same for hidden 1 and 2, I won't describe them again, and I'll pass over to Eleanor.
Cool. Are you all right to keep control of the slides? We'll just do a next slide, please, type thing. Cool. So hidden 3 takes an integer as an input, and if the integer is positive, then it returns the square of that integer. And if it's a negative integer, it deals with the absolute value and it gives you the nth Fibonacci number. which was a bit confusing for me because you're assuming the Fibonacci sequence starts with 1, 2, but like traditionally, I guess it starts with 0, 1. So for example, if you put in -5, it gives you 8, which is the 5th Fibonacci number. Next one. Cool. So 4 and 5 handle strings. Hidden 4 turns a string into title case. So it takes the first letter of each word and turns it into a capital. Becky wrote a try except block so that it would refuse to deal with floats and integers. While we were working on it, we found that there's an inbuilt function in Python called title that basically does the same thing. But actually what Becky's done is far superior because the title function turns everything after any symbol into a capital. So like '(S) would make the S a capital, which is not really what you want from title case. Next one. Cheers. Hidden 5 turns a string, splits it into individual words, and then reverses each of the words and gives you back a kind of garbled mess to kind of obfuscate it a bit, I guess. So Catherine worked on this one, and one of the things that she did to make it easier to understand what was going on was there was a redundant variable in there, just a random Boolean variable called b. Through trying to figure out what that did, she realized it didn't really do anything. So she just got rid of it to make it a bit clearer in her reverse engineered code what was going on. Last one. Okay, so the bonus script starts with a long string of IP addresses, which has been discussed already, and it seems to be pretending to make GET requests. But then if you look at it, it's making a GET request from Google every time. So that's, while we were working on it, started to think that those IP addresses didn't have anything to do with the GET requests, actually. So we figured out that what it's actually doing is reversing all of that data, those IP addresses, which also contains a bunch of functions that all reverse as well, spits them out into a new file, and then pretends to call 2 random functions on that kind of list of reversed IP addresses. But on further inspection, the random number generator was being seeded. So it's told which number to start at each time. It was seeded with 31. So it was always calling the same 2 functions on the reverse list of IP addresses. Those functions were ping first, and ping was doing 2 things, essentially to convert the reversed IP addresses into byte data and then into string data, which was a piece of code. Then the inbuilt function exec ran that code, which gave you a new file with the secret message inside. So those are all of the scripts that we worked on, that we reverse engineered. I just wanted to quickly say thank you to CFG and GCHQ for organising everything, and thank you to Becky and Catherine for being great to work with and making it really fun. Thanks very much.
Guys, that was really great. I think it's for the people that have taken part in this who have never done any coding before, to be jumping straight into this sort of stuff is just like, it's tricky stuff. And I think it's really impressive kind of what you've done and how you've done it and how you've approached it and stuff. So, you know, just well done. I think for me, like when I've been learning to code, actually having something practical that I can see the use of the code is something that definitely helped me a lot. So I think these sorts of challenges are perfect for that sort of thing, because you're like, oh, right, this is what you would actually use this for, rather than just reading, you know, some really dry text about various functions and things. So yeah, that was great. So let me add Raz back onto the stage, and I'll add Sam on as well in case Sam's got any questions. So yeah, if anyone's got any questions, please fire away.
Very well done. I'll repeat, for someone who's just started learning Python, to getting through these challenges is really impressive. We weren't expecting many people to get through to the end, let alone as many of you guys have done. So very well done for picking away at these problems and trying to uncover what was going on. Especially liked your explanation of the bonus script with each stage, including the seeding we were doing to try and confuse people with the randomness. I was curious, what was your process when you started realizing the request wasn't quite the request you thought it was, or the normal one?
I think once I saw that random was being imported, I got a bit suspicious, to be honest. And I did notice that there were some reversed functions in there. But then because one of the functions was called like whatever it was called XOC1, I knew something was up basically. But yeah, it was really tricky. So thank you for designing something so hard, because it was quite satisfying in the end.
Cheers. Thanks.
Yeah. I just want to say that I'm super proud of every one of you, because just like what Jody said, I mean, it's really beautiful to see individuals with very little experience prior to the beginning of this MOOC, and then move on to developing something this beautiful. Like, it says a lot about the quality that had been given out, and also about the um, the input by the students. So I just want to say I'm super proud. I have one question, because I found your presentation to be very simple. So I mean, so simple that someone who probably had very little understanding could follow up. So just one thing that could help me understand how you were able to maybe simplify this is, and a huge part of being a programmer is being able to understand stuff on your own. And this means leveraging various means, maybe searching the internet, documentation, just, trying to like unravel things. So I want to understand, I did see certain things within the Python tasks that weren't really taught out of the box from our sessions. So I want to know, how did you go around understanding those certain syntax? I saw requests. I don't think we actually did requests, did we? So how did you go around like unraveling and trying to like deciphering those syntax and keywords and logic that weren't really taught in the session? That's my question.
I think for the most part, if I don't know what something's doing, I just Google it, which sounds ridiculous. Sorry, but I'll go on like Stack Overflow or similar and try and find out what's going on. And we talked quite a lot in our Slack channel as well about the things that we'd found out. So that was really helpful to have someone to speak to about it, because you can think you understand it, but then once you can discuss it, you actually feel like, oh yeah, we all get this. We're on the same page. Yeah. Becky, do you want to add anything?
Yeah, no, I pretty much did exactly the same. Like the sys module, I had no idea what that was because that wasn't covered in the MOOC. So I just did a lot of Googling. Also, as I mentioned, we had kind of a working document that we put all of our kind of thoughts in about, because we split all the programs between us. So once one of us had a go at one program, the other girls could check it. And that was really helpful because both Ellen and Catherine would pick up stuff that I didn't pick up. And also, I didn't have an IDE before this. So I downloaded VS Code, and that has kind of inbuilt, it tells you when stuff's a bit wrong, so you can, and gives you helpful messages. So it was just kind of Googling and trying to use resources and help from the rest of the team as well.
Awesome. Well done.
Great stuff. Well, if we do not have any other questions from anybody, then what we are going to do now is we are going to give our lovely GCHQ judges 5 minutes to deliberate and make a decision on who the winner is. So the stream is going to stay live. We'll just basically have this sort of MOOC challenges holding slide here for the next 5 minutes. While GCHQ deliberate and make the decision, and then we will come back on and make the announcement. So what are we on now? We are on 19 minutes past, well, in fact, it was gone to 20 past. So we will come back at 25 past 8 to announce the winner. Right, everybody, we are back. I hope you've had an enjoyable 5-minute break. I'm just going to add Raz back onto the stream. And I will let them make the announcement. So take it away.
Thank you very much. This was not an easy choice. You may have noticed for our little break there. We were kind of arguing between ourselves as to who would impress us the most here. But I want to repeat, like, when we were setting these challenges, we were struggling with knowing what level to set these at, and we assumed that the bonus challenge at the end was really going to push you guys, especially for those of you that are very new to Python. Like, this is not easy stuff, not stuff that normally comes up in a Python course. But we hope that it being different would make it interesting. And you guys have really excelled and pushed through. Personally, I was thinking we would be turning up here and be walking through the final challenge for you guys, but you guys have managed to do it, which is really impressive. And we mention we used some techniques from real malware that has been seen in the wild. So yeah, it was really impressive. And now getting to our selection, I think first I'll say for Team Green, we really liked your the way you presented it with the video style. It was really nice to be well done. And our winners were Team Line. Thank you very much to the final group. Really well presented overall, really thorough detailed explanations of everything and the steps you'd gone through, and it was really impressively done. And I also want to give out a special mention for Janet, because you were working on yourself through this, which is quite impressive, not having that extra soundboard to talk through the problems and an extra pair of eyes. So it's impressive that you did that, and also you were thinking beyond the challenge we'd set, which is really impressive, and really sets you up for someone who's would be really useful in defensive cybersecurity. Think about where potential pitfalls were, even if they're not right there in front of you. That was really nice to see. But yeah, overall, Team Line has won it for today, I think. Thank you very much, everyone.
Awesome. That's amazing. Thank you, Raz. Thank you so much for coming along and judging, and for setting the challenge as well. As I think we've all said, it was a really challenging one, particularly for people that are such beginners. So yeah, I've been really impressed by seeing what everybody's done. I thought everyone's presentation was great, and everybody absolutely smashed it. So yeah, well done, everybody. So that's pretty much the end of what we've got for you this evening. So we just want to say a big thanks to everybody. So a big thanks to GCHQ for sponsoring and obviously coming along this evening. I'd also like to say thanks to Sam, if they're still around and they want to say anything else. I just think what everybody has achieved is really great, and hopefully you're all going to carry on and do some more MOOCs, maybe do some Kickstarters, maybe even think about the CFG degree, or any sort of other coding things. It doesn't have to be through CFG, of course. Those are just the CFG options that are available for you. But there's tons of ways to learn coding and put things into practice out there. So please just kind of keep at it. And yeah, if anyone's got any questions or anything, then we will still be on the Slack. So if you've got any questions about anything, then please do drop them into the Slack or into the YouTube chat if you are live on the call now. So yeah, Sam, I don't know if you've got any final closing words for us, but yeah.
Yes, I always have a final closing word. So I just want to say, I mean, this step you've taken is super cool, and it's one of many steps you would take in your career. So I'm talking to like every student, everyone enrolled on this course. Software engineering, data science, being a programmer is a lifelong journey. So taking this MOOC, and as well maybe any other MOOC, is actually going to help you become better. So do look out for MOOCs that also practical based, just like this very one, okay, like having to implement the things you've learned. And also look out to, stepping up to maybe getting on some CFG degree course, or, just stepping up your learning. And well done. I'm super proud, very, very proud and honored to be your instructor. And I look forward to, having you ask more questions and become more inquisitive and enthusiastic about programming. And that's it for me. Thank you very much.
Great stuff. Wow, thanks very much, guys. And yeah, hopefully we'll see you all in some later courses. Thank you, everybody. And I will close the stream there.